When installing a 100 amp subpanel in a garage fed from a 200 amp service, it's crucial to adhere to the National Electrical Code, or NEC, guidelines for conductor sizing. Using the wrong size conductor can lead to code violations and potentially unsafe conditions. For a 100 amp subpanel subfeeder, the NEC specifies a minimum conductor size to ensure it can safely handle the load. The National Electrical Code Section 310.15b7 states that conductors for subfeeder shall have an ampacity not less than the sum of the branch circuit ampacities supplied by the subfeeder. In the case of a 100 amp panel, it can supply 100 amps of branch circuit current. Therefore, the subfeeder conductors must have an ampacity of at least 100 amps. According to the NEC Table 310.16, the ampacity of 2 aluminum conductors is 95 amps. This means that 2 aluminum conductors are not sufficient to carry 100 amps. To meet the NEC requirement and ensure safe operation, you should use 3 aluminum conductors. Each of these aluminum conductors must have a minimum ampacity of 95 amps, but since this exactly matches the ampacity, it is better to go to the next wire size to exceed the 100 amps in case the wire temperature rises beyond the 30 degrees Celsius rating in the table. It's important to consult the latest edition of the NEC and any local amendments for the most accurate and up-to-date requirements. Local codes may have additional restrictions or requirements that must be followed. Always prioritize safety and consult with a qualified electrician if you have any doubts or questions about electrical installations. Proper conductor sizing is essential for preventing overheating, voltage drop, and other potential hazards. Remember to consider factors such as the length of the feeder run, the type of insulation, and the ambient temperature when selecting the appropriate conductor size. For example, longer feeder runs may require larger conductors to compensate for voltage drop. Different insulation types have different temperature ratings, which affect the ampacity of the conductor. Higher ambient temperatures can also reduce the ampacity of the conductor. It's also important to ensure that all connections are properly made and torqued to the manufacturer's specifications. Loose or corroded connections can cause overheating and arcing, which can lead to fires. Always use the correct tools and equipment for the job, and follow all safety precautions. When working with electricity, always turn off the power at the main breaker before starting any work. Use a voltage tester to verify that the power is off before touching any wires or connections. Wear appropriate personal protective equipment such as safety glasses and gloves. Never work alone, and always have someone nearby who can assist you in case of an emergency. By following these guidelines and consulting with a qualified electrician, you can ensure that your electrical installations are safe, code compliant, and reliable. The NEC provides a comprehensive set of rules and regulations for electrical installations, and it's essential to adhere to these guidelines to protect yourself, your property, and others from electrical hazards. Remember to always prioritize safety and consult with a qualified electrician if you have any doubts or questions. Electrical work can be dangerous, and it's essential to take all necessary precautions to prevent accidents and injuries. Proper planning, careful execution, and adherence to the NEC are essential for ensuring a safe and reliable electrical system. Consider the environmental conditions the wire will be exposed to. Factors like moisture, chemicals, or extreme temperatures can affect the wire's insulation and overall performance, so choose wires specifically designed to withstand those conditions. Also, ensure the conduit or raceway you're using is suitable for the environment as well. This is a critical step for long-term reliability and safety. The type of load the subpanel will be serving is important. Are you planning on using heavy machinery, power tools, or other equipment that draws significant current? If so, it may be wise to oversize the conductors slightly to accommodate for potential future expansion or increased load demands. This will help prevent overloading the circuit and ensure reliable operation. Breaker sizing is also important. The overcurrent protection device, like the breaker, should be sized appropriately for the conductors it is protecting. Using too large of a breaker can allow the conductors to overheat and potentially cause a fire. Consult the NEC for proper breaker sizing based on conductor ampacity. In addition to the size of the conductors, also consider the type of insulation. Different insulation types have different temperature ratings, which affects the ampacity of the conductor. Choose an insulation type that is suitable for the operating temperature of the circuit. Always use listed and labeled electrical components. This ensures that the components have been tested and meet safety standards. Using unlisted or unlabeled components can be a safety hazard. Proper grounding is crucial for safety. Ensure that the subpanel is properly grounded to protect against electrical shock. Follow the NEC guidelines for grounding electrode systems and grounding conductor sizing. Also, use appropriate grounding techniques for the type of wiring method being used. After completing the installation, thoroughly test the system to ensure that it is operating properly. Check for voltage drop, proper grounding, and any other potential issues. Use appropriate test equipment and follow safety procedures. It is advisable to get a permit and have the work inspected by a qualified electrical inspector. This helps ensure that the installation meets all applicable codes and standards. The inspector can also identify any potential issues that may have been overlooked. Always keep accurate records of the installation, including wire sizes, breaker sizes, and any other relevant information. This information can be helpful for future maintenance or troubleshooting. Remember that electrical work can be dangerous and should only be performed by qualified individuals. If you are not comfortable working with electricity, it is best to hire a licensed electrician. Consider the use of surge protection devices to protect sensitive electronic equipment from voltage spikes. Surge protection devices can be installed at the main panel or at individual outlets. Be aware of the potential for electromagnetic interference or EMI and take steps to minimize it. EMI can interfere with the operation of electronic equipment. Use shielded cables and filters to reduce EMI. Plan for future expansion. If you anticipate needing more power in the future, consider installing a larger subpanel and conductors than are currently needed. This will save you the cost and hassle of upgrading the system later. Always follow the manufacturer's instructions for installing electrical equipment. The manufacturer's instructions provide important information about the proper installation and operation of the equipment. Use appropriate wire connectors and terminals. Wire connectors and terminals should be sized appropriately for the conductors being used. Use connectors and terminals that are listed and labeled for the intended application. Protect wires from physical damage. Run wires and conduit or raceways to protect them from physical damage. Use appropriate fittings and connectors to ensure that the conduit or raceway is properly installed. Keep electrical panels clean and free of debris. Dust, dirt, and other debris can accumulate in electrical panels and cause them to overheat. Clean electrical panels regularly with a vacuum cleaner or compressed air. Label all circuits clearly. Labeling circuits makes it easier to identify the correct circuit for maintenance or troubleshooting. Use a permanent marker or label maker to create clear and accurate labels. Inspect electrical systems regularly. Regular inspections can help identify potential problems before they become serious. Look for signs of damage, overheating, or corrosion. Address any problems promptly to prevent further damage or safety hazards. Keep a fire extinguisher nearby. In case of an electrical fire, it is important to have a fire extinguisher nearby. Use a Class C fire extinguisher, which is designed for electrical fires. Know how to shut off the power in an emergency. In case of an electrical emergency, it is important to know how to shut off the power. Locate the main breaker or disconnect switch and be familiar with how to operate it. Educate yourself about electrical safety. The more you know about electrical safety, the better prepared you will be to prevent accidents and injuries. Take online courses, read books, or attend workshops to learn more about electrical safety. Remember that electrical codes and regulations are constantly evolving. Stay up to date on the latest changes to ensure that your electrical installations are compliant. Subscribe to industry publications, attend seminars, or consult with a qualified electrician to stay informed. Proper planning and execution are essential for a safe and reliable electrical installation. Take the time to do the job right, and always prioritize safety. It is highly recommended to consult with a qualified electrician for any electrical work, especially if you are not familiar with electrical codes and safety practices.